Hello and welcome to Math for Fun, and here I'm going to show you how to do vector operations using calculator Fx-991EX easily. First of all, we need to reset the calculator because maybe we have done some operations and we added some memory to the calculator. So you should reset the calculator by pressing Shift 9, 3 and then reset all. Let me show you how do you do that. Go to the calculator, press Shift 9, 3 and then choose equal sign. And then press AC, and now your calculator is in the reset mode. So nothing added to the calculator. All the memory has been cleared. Let's go for example number 1. Here we have vector A equal to 2, 3 and vector B equals to 3 minus 1. We need to do 2 times vector A minus 3 times vector B. Now, if you see that I wrote vector A without the letters VEC, why? Because sometimes you find it in the books or somewhere it's written just A and they put the brackets like different than when they represent it in a point, because in a point they make it like parentheses, but here they make like it's broken parentheses if you see like the sign smaller or greater. So here it means that this is a vector A with components 2, 3. And here I wrote vector B also to know that sometimes they wrote vector B with the letters VEC. It represents vector B in this case. So vector B equals 3 and minus 1. So both are accepted. I wrote it both just to make sure that you know that you can use it. So now here we wrote 2 times A minus 3 times B. Also it represents by 2 times vector A minus 3 times vector B. How do you do that on the calculator? As we did in the video of matrices, if you remember, we have to define the vector. To define the vector, first we change the calculator to the vector mode. So we go for menu and we go for vector, which is number 5. So we press 5 and now the calculator in the vector mode. So we have to define the vector. To define the vector, let's say vector A. Vector A, which is 2, 3. So we choose number 1. And then it will ask you vector A dimensions. What are the dimensions of the vector? We have vector with dimension 2, vector with dimension 3. So we choose 2 because here we have two numbers, which is x and y. So we pick up 2. And by pressing 2 here, we get the vector A. Here we have to put the components of the vector. What do we have? We have 2, 3. So we press 2 and then equal and then 3 and then equal. And here the vector A has been defined and we move for vector B. So press AC and we go for option and we define another vector, which is vector B. Let's put 1 and then we put vector B, we choose 2 and then also dimensions 2 and then we put 3 minus 1 because here we have 3 and minus 1 for vector B. So put 3 equals minus 1 equal and then we got the vector B. So press AC and now whatever you want to do with the vectors, you do it exactly by similarly what we do the operations, but to recall the vector A and vector B we have to go for option and recall the vector and choose which vector you have added. So now here we have 2 times A minus 3 times B. What do? We put 2 times, we recall the vector A, go for option and choose vector A, which is number 3. So we press 3. You see 2 times vector A now. So we finished the first part. Now we have minus 3. So we put minus 3 times and we go for option and we choose option 4, which is vector B. So we put 4. Now here we have all the operation here, 2 times vector A minus 3 times vector B, and we press equal sign and we got the vector minus 5, 9. If you can see this number, usually they put it here. It's minus 5. So if you want to see the second one, go down one step, you get this as 9, and here we got the answer of this question. So vector operation is similar to the matrix operation as we have done in the previous video. So just follow the steps and you get the answer for all of your questions. Let's go for another example. Here we have A cross B. A cross B means cross product. If you see that there is a cross product and there is something called dot product, you will see it here. There's a dot. So dot product and cross product. Let me show you how do you do that with the calculator. Let's clear here AC. Now we have vectors. So we have the same vectors 2, 3 and 3 minus 1. We want to do the vector dot product. So we have to recall the vector A. Let's recall the vector A. So go for option and we have vector A by number 3. So we put number 3. Remember, if you want to do the dot product like starting from scratch, you have to define the vectors. You have to define the vector before you do the dot product or cross product. You cannot start straightforward because there is nothing in the memory of the calculator. So make sure that you define the vectors and then do the cross or dot product. So now here we have vector A. Now we go for option and go one step down, and here you see dot product number 2. So we choose 2, and then we go for option again, and we go for vector B number 4. That's number 4 here, and we got vector A dot vector B and press equal. Then the answer is 3. And if you don't remember the dot product, let me remind you. The dot product between two vectors is the sum of the products of the x's and y's. Like you do 2 times 3 plus 3 times minus 1. Like x1 times x2 plus y1 times y2. So 2 times 3 is 6. 3 times minus 1 is 3. 6 minus 3, which is 3, which is correct here. So that's the dot product. Now let's go for the cross product. Now to do the cross product, use this sign, which is the multiplication, to perform the cross product. So what do you do here? You go for option and choose vector A as 3. So press 3 and then make this multiplication and go for option and choose vector B, which is 4. So press 4, and then here we have vector A times vector B, which is the cross product. Make equal sign, and then you get the vector multiplication, which is 0, 0 minus 11, and that's the answer of A times B, like vector A cross vector B. Let's go for another idea. The magnitude of a vector. How do you do the magnitude of a vector? To do the magnitude of a vector, we have vector A equals to 2 and 3, x and y. And you know, to find the magnitude, we do radical a squared plus b squared, or radical x squared plus y squared. X squared, which is 4, y squared, which is 9. 4 plus 9 is 13. So you get radical 13. But to do that on the calculator, let me show you how do you do that. Here we have something called absolute. If you see this sign here, this key, there's an absolute, ABS. ABS means absolute. So we press shift and we press this key, you get absolute of something. Now we need to put the vector A inside the absolute value, like here. So to put the vector A, we go for option and we choose vector A as number 3. We put 3, we close bracket and we press equal, and then you get the answer 3.605, which is radical 13. I'm not sure if you press the S, there's no way to make it radical 13. So usually, sometimes if you get, let's say, an answer as a fraction or decimal, you press the S to D key, it will give you the radical form of that number. Now here, it doesn't work. So we have 3.6055. And you remember, we calculated the magnitude manually, we got radical 13. Let's check if you do radical 13. We go for mode 1 to normal calculation, and we do radical 13 equals, in decimal form, is 3.605, which is the same answer. So we go back to menu, vector, number 5, and we see the other question. Let's check the other question here. Here there's something cool in the calculator, which is the option to calculate the angle between two vectors. So here we have vector A, which is 2, 3, and vector B equal to 3 minus 1. If you already done that and you entered the vectors or you defined the vectors in the calculator, no need to define it again, but let's start from scratch. We have vector A, so we go for option and we define vector. Let's go for number 1 and we say number 1, which is vector A, press 1. And we have dimension is 2 because we have 2 and 3. We have x and y. So we press 2 and then we put the vector components. We put 2 equal 3 equal and finish vector A. Let's go for option and we define vector number 1 and we put vector B, which is 2 also. Dimensions also 2 and we put 3 minus 1. That's 3 equal minus 1 equal, and now we have vector A and vector B defined to the calculator. We want to find the angle between the vectors now, so we go for option and we go one time downward and we have angle here. You see that angle, which is number 3, so press 3. So we have angle between the two vectors. What are the vectors? We choose option, vector A, which is number 3, and we put the comma sign here, which is shift, the closing bracket, which is inside, you see that sign, and we put option and then we put number 4, and that's vector B. We close the bracket and we click equal, and here is the angle 74.7448813. Remember that the calculator is in the degree mode. If you want the angle in the radian mode, you need to go for shift, menu, and then angle unit, which is number 2. We put 2, and then we choose radian, which is also number 2, and we need to press equal one more time, and then we get 1.3, but this one is in radian. 74 is in degree, 1.3045, it's in radian mode. So if you want it in radian, remember to change the calculator to the radian mode. If you want to keep it in degree mode, make sure that the calculator is in degree mode. Now here we finished the angle between the two vectors. Let's go for another idea. Unit vector. We can find the unit vector by using the calculator. If you don't remember the unit vector, the idea of the unit vector, look how many steps you need to do to find the unit vector. Here they say find a unit vector in the direction of vector v equals to 2 and minus 3. The first thing, you need to calculate the magnitude of the vector. How do we calculate the magnitude? We mentioned that in previous question. We do radical x squared plus y squared. Let's say 2 squared plus minus 3 squared, which we got previously also, let's say 13. So here we have radical 13. So what do you need to do? We have to divide the vector itself by the magnitude of the vector. Like the components of the vector, we put them and we divide them by the magnitude of the vector. Like 2 divided by radical 13 and minus 3 divided by radical 13. So look how many steps you need to do that. But in our case, here we have vector A. And to find the unit vector of vector A equal 2 minus 3, let me show you how do you do that on the calculator. Already we defined vector A, which is 2 minus 3. First of all, we go for option, and we go down, and we go for number 4, which is unit vector. So we press 4. Here you see unit vector. So now we want to recall the vector that we have to find the unit vector for it. For which vector you need to find the unit vector? Let's try it for vector A. So we go for option, and we go vector A, which is number 3. So press 3. So here you see unit vector of vector A. We close the bracket and we press equal, and here you see the components of the unit vector. The components of the unit vector 0.5547 blah blah, and which is here, and here you have 0.832, which is the y. And as you know that the unit vector has a magnitude of 1. That's why they call it unit vector, because if you find the magnitude of the vector, it should give you 1. Let's prove that. Here we got the unit vector of vector A, and as you see here, it assigned a name, vector answer. You see vector VCT ANS equal to this, which means that we can use that to find the magnitude of this vector. How can we find it? If you go for option and you go one step downward, look at that. Here we have VCT ANS, which is the one that we got now, which is the vector answer we got in the previous step. So what we can do here, we can go for absolute value, we go for shift ABS, and then inside we put option, and we go down and we choose number 1, which is vector answer, which is number 1, and we close bracket and we press equal, and look how much did we get? We got 1, which means that the unit vector has a magnitude of 1. We mentioned before that ABS means the magnitude of the vector, and here we have vector answer, which is the unit vector of this one. Its magnitude is 1. And here I can say that we reached the end of the video. If you like the video, don't forget to like and share, and welcome to Math for Fun, and bye for now.